in part B. So this was part A, m prime of t, negative 4t plus 100. Part C. Find the marginal productivity when t equals 5, 10, 25, and 45, and interpret the results. Okay, so I am just going to try to squeeze them in here because I would like to see them in the same table together. So m prime of t. So I'll put the function in. Where is it? Right here. Second function, negative 4t and plus 100. Good. So I have them already because everything is there. So 80, and then 60, and then 0, and then negative 80. Okay, perfect. Let's interpret the results. So I'm going to write here C above. So let's interpret the results. So after 5 years, the productivity is 630, and the rate of change is 80, positive. After 10 years, the productivity is higher, but it does not increase. The rate of increase is not as fast as it used to be. After 25 years, the productivity is this, but it flattens. So in other words, there is no hope from here. It reached 0. Maybe I shouldn't say there is no hope, but it reached 0. And look what happened next. After 45 years, the productivity decreased, and it continues to decrease. It has a negative rate of change. So that's the idea here. Any questions? Any questions for me?
Is the table like a good amount of work to show in our homework? Like there's really not much more else we really need to show?
No, for this particular problem, nothing. I'm happy with this. Okay. If you want, you can add just one sentence, add that the rate of change is decreasing. The rate of change of productivity per year is decreasing. Initially it's 80, and then it's 60, and then it's 0, and then it's negative. Okay, so we are ready to move on to the next section. 3.7 is not part of the class, so we move on to 3.8, in which we are going to learn 2 techniques. One technique is called implicit differentiation. And the other technique is logarithmic differentiation.
Wait, pardon me, wasn't that 3.6 we just did?
Yes, it was 3.6. 3.7 is not part of the class. 3.7 is not part of the class. We move on to 3.8.
Okay.
Elasticity of demand is not part of the class. So we only have 3.8 and 3.9 left from this chapter. Okay, so let's see what implicit differentiation means. So what is direct, first of all? I never mentioned direct differentiation. And what is implicit differentiation? Here I'm given the function. F of x is 3x squared. If you ask me find the derivative, what would you tell me to write?
Exactly.
X.
Done. But now look here. Where y is a function of x. Find dy over dx. You can write f prime of x. Please don't. It's not wrong. It's not useful. This is the better notation of these two for this situation. Here I was directly given the function. Here I'm given the function in an implicit way, through an equation. I cannot solve this equation. No one can. For y. A calculator will. I should say if a software, a computer will, but a human being will not. So can I still find an expression for the derivative of this function? The answer is yes. By implicit differentiation, or differentiating both sides to find dy over dx. Here the function was given direct. I was able to differentiate directly. I was given the function. Here I'm given the function, but in a roundabout way, in an equation. And since I cannot solve it, I can still find an expression for dy over dx. You could say, oh yeah, you can, but it will still depend on y. Yes, it will. So exactly how we said we had e to the x equals 2 and we apply natural log to both sides, same thing here. I can differentiate both sides. In the same way I applied this function to both sides, or apply the square root to both sides, etc., etc. In the same way, I can differentiate the left and I can differentiate the right. Keeping in mind, and I'm going to put it like this, remember y is not a variable, but y is a function of x. So we have to treat it as a function of x. Okay, so let's do that. So let's do this together because this may appear difficult at first. Okay, so one more time, I will emphasize that this is a function. It's not a variable. So we will differentiate both sides. Can anyone help with the function to the third power, prime? A function to the third power prime. What is the formula or the rule that we apply for a function to the third power prime? We bring 3 down. We do what?
-1.
Good. Times
The function.
prime. Excellent. Plus. This is a product. Can anyone differentiate the first part first for us?
2x, 4x.
Good. Times the second function plus 2x squared. Can anyone give us the derivative of y?
1.
That's why I put it underneath. That's why I emphasized with this sign. Y is not a variable. Y is a function. What is the derivative of y?
Y. dy dx.
Exactly. Equals. Can anyone give us the derivative of this?
8x.
That's it. See what happens now. This is our variable. These two terms have the variable. This one does not. This term has to go to the other side. These two terms have this variable in common. I will pull this out. What is left in parentheses when I pull dy over dx? What should I write in parentheses? That's it. Equals 8x minus, this is our variable. How do I solve this equation for this variable? I covered it because I don't want you to get confused. I know it's an ugly variable looking, but it's just a variable. How do I solve? Yes?
You would divide both sides by
Of
3y
course.
squared.
Exactly. That's it. That's all we need to know about implicit differentiation. That's it. So we found an expression for the derivative, although we don't even have the function. We found an expression for the derivative. Let's look at an application now.
Really quick, I'm just a little confused about the why the 4xy isn't part of that. Could you just kind of go for that again one more time?
Yes. So this term has the variable. This term has the variable. This term does not. Our variable is dy over dx. This term does not have dy over dx. That's why it has to be moved to the other side. If I had here dy over dx, I would have had in parentheses 3x squared plus 4xy plus 2x squared. But this one does not have dy over dx. I'm not solving for y. I'm solving for the derivative of y with respect to x. Is that better?
Yes, I understand a bit more now. Thank you.
Yeah, you will feel better after the second example. Okay, so let's say we have 23 on 359. So we have x to the fourth minus x squared y cubed equals 12. And they want us to find dy over dx and then find the slope of the curve at the given point. So in other words, they're giving us a point. I'd like to call it P, -2, sorry, -2, 1. Okay, so once I find this, not a problem. I'm going to say x equals -2, y equals 1, and plug it in. But I'm not there yet. How do I find dy over dx? I can. This is actually, it's a much simpler situation. I could solve for y, but I don't want to. Too much work. There is no need. So what should we do to both sides to find dy over dx? What did we just do? How did we determine dy over dx? We differentiate both sides, Can anyone differentiate x to the fourth for us?
4x cubed.
That's it. Minus, because it's minus and this is a product, I'm going to leave it alone. And I know that inside I have to have two terms. Why? Because it's a product. And the right-hand side, when I differentiate 12, what do I get?
Zero.
Excellent. Good. Can anyone help with the differentiation of this product? We differentiate the first function, what do we get?
Is the first part 2x y to the third?
Excellent. Plus x squared times, how do we differentiate y cubed? We just did it a minute ago.
3 y dx.
Squared
Yes.
times,
dy dx.
excellent. That's it. So now careful, let's distribute this. So 4x cubed minus 2xy cubed minus 3x squared y squared dy over dx equals 0. How many terms have the variable we are interested in? Anyone? How many terms?
Only one?
Exactly. Which means that these two have to go to the other side. So negative 3 x squared y squared dy over dx equals, I'll put this one first because it becomes positive. I'll put this one second because it becomes negative. Good. So now can anyone solve for dy over dx for us?
Just divide by negative 3x squared y squared.
Excellent. All I have to do now, plug in the numbers they gave us. And this is done. So 2 times negative 2, this is negative 4. 1 to the third is 1 minus 4. Negative 2 to the third will be negative 8 over negative 3. Negative 2 squared will be 4. And 1 squared is 1. Do not simplify in a sum, please. So I have negative 4 plus 32 over negative 12. I have 28 divided by negative 12. I'll simplify by 4. And I get negative 7 over 3. This is the slope of the tangent